All right, what can we do with this? Let's play with it. So this is an application of the half angle formula. If you don't have it memorized yet, just look it up. So trig cheat sheet, lately I like this one from Clark University. It says the cosine of half an angle is equal to either positive or negative, that depends, square root of the fraction 1 plus cosine of the original angle over 2. So you have a half angle and a full angle to consider there. So usually I like to write down the identity rather than just look at it on another piece of paper. So cosine, let's use their gamma over, it's not a very good one, over 2, well, I'm not used to writing that one, is equal to either plus or minus, we'll have to evaluate that, depends on the quadrant that we're in, 1 plus the cosine of the original angle, a little better, over 2. Okay, and then we're given the cosine of gamma is that number right there. So they're telling us what this number is right there. So really all I need to do is plug that number in here and then note that I'm in quadrant 1. So what does it mean to be in quadrant 1? Think about the unit circle. In the unit circle, the cosine is an x value. So we have some x value in here. Let's see, here they're saying the cosine of the original angle is a negative number. That puts it over here. But again, we're looking at cosine of half that angle. So let's see, 1500 over 1600. So that's pretty close to over here-ish. So that's the original x value. That leads to this point right here and this angle right here. So that angle right there is the angle gamma. That looks more like a alpha. Let's try again. Oh, a little better. Now we want half of that angle. Half of that angle is going to be over here. So this angle right here is gamma over 2. And notice it's going to have a positive x value. And we want the angle that is in quadrant 1. So that means we're going to go with the plus here. If that angle ended up being in quadrant 2, say, we would want the minus version of that. So I can get rid of the minus. We want the plus because of the position of that angle compared to the other one. And then we just plug in. So cosine of gamma over 2, gotta work on my gammas there, is equal to the square root of 1 plus, and then they say that the cosine of gamma is this number right here. So negative 1/1519 over 1681 all over 2. And we just whip that into a calculator. And we got it. Not bad. So it's just a pretty straightforward application. Can I remember those two numbers? Probably not. So square root fraction 1 plus a negative is going to be a minus. Another fraction 15 something, 1519, 1681. All divided by 2. And we get that right there. And this is probably not a perfect square there. I guess I could try to calculate it and see, but I seriously doubt it. Can Desmos turn it into a fraction? Oh my gosh, Desmos could. Now I'm curious. All right, so to do that, let's see if we can do it without the calculator. We're going to have to do a little more arithmetic. So we need a common denominator for the numerator here, which would be the 1681. So that's going to give us 1681 over 1681 minus the 1519. And dividing by 2 is a multiple of 1/2. So let's see if we can do this here. So 1681 minus 1519, what does that give us? 1681 minus 1519 is 162, and then we are cutting that in half. So 162 divided by 2 is 81. Oh my gosh, so there's the 9. Let's see, notes please, there you go. So this numerator here was 162, and we divided that by 2, so that gave us 81. So we now have the square root of 81 over 1681. So I know square root of 81 is 9, and according to the calculator, that denominator ought to be, square root of that should be 41. Let's double check. Square root of 1681, oops, 81, I could type. Hey, check it out, it is 41. So it turns out this one comes out very nice. Thank goodness for Desmos. This would have been only marginally harder without. So 9 over 41, and let's think about that. 9 over 41, that's kind of like 10 over 40-ish, which is 1/4. And yeah, so my picture's kind of rough, but I could say, yeah, that's around 1/4. I'll buy that. So 9 over 41 seems to be that X value there, which is what we were asked to find. Good question.